So this video is for ECE 231 students, and what I'm going to be doing here is assuming that you've never worked with an Arduino Uno before, and I'm going to build a simple application that causes some LEDs to turn on or off depending on the position of a switch. And so let me just start out here by sharing screen. Okay, that should be shared with you here already. And this is the code we're going to be working with. I'm calling this switches3.c. Now, I had already showed you switches2.c in class, and we discussed that. And that was code that just had buttons on pins PD3 and PD4, LEDs on PD6 and PD7. And we made the buttons input pins and the LEDs output pins, and we set the internal pull-ups on those inputs. And then we had logic to detect whether the buttons were pressed or not, and turned on the LEDs accordingly. Now, switches 3 I just made, and it's the same functionality, but the code is cleaned up a little bit that should make it a little easier to understand. So it functions the same. The function of this code is going to be that we press one button and a red LED is going to glow, and we press the other button and the green LED is going to glow. But notice that I have some additional defined macros in this code. So we're going to be using PD3 and PD4 for our buttons controlling the red LED and the green LED respectively. So I decided to define some macros, one called red button. And so that's going to be equivalent to PD3. And that will correspond to Arduino pin 3. And then the green button, that is the button controlling the green LED, will be port D pin 4, and that corresponds to Arduino pin 4. And notice the correspondence here. When we're using port D, pins 0 through 7, that's the full byte of port D, they correspond to Arduino pins 0 through 7. And so we have the buttons on PD3 and PD4, and we also will have the LEDs on PD6 and PD7, which correspond to Arduino pins 6 and 7. Okay, and I just define these macros because then later on in the code, I don't really have to think about PD3, PD4, PD6, PD7. I'll just go by these macro names. Okay, the other thing that I've done in here compared to the previous code is in line 15, I've declared 2 additional variables. They're type unsigned char, so that just means that they're a number between 0 and 255. And I call them R button and G button. And those are going to just be the status of the buttons, whether they're pressed or not. And now, just a little bit, you'll notice that you have some capital things that are done in capital and things that are done in lowercase. A rule, this is not a coding rule, but it's a style rule, is that whenever you're doing a defined macro, you do all that in all capital letters. And then when you are defining variables, you use lowercase. That way you can quickly see which is a variable and which is a macro. Okay, so down here, line 16, I'm setting those 2 LED pins as outputs. Okay, so, one shift left red LED or one shift left green LED will assign those pins as outputs. Then line 17 is going to set up the internal pull-up resistors on the buttons for red button and green button. Okay, then we get down into the logic, and all I want to do is I want to check, is the red button pressed? And if so, I want to turn on the red LED. And if the green button is pressed, turn on the green LED. And so I've coded this a little differently. This variable here, line 21, I have my variable R button, and I'm assigning that to a value, a true, false, or a 1, 0 value, depending on the status of the red button. So if red button is pressed, then you would have a 0 in this bit position, and R button would be 0. So you'll have R button equal to 1 when it's not pressed and 0 when it's pressed. And likewise for G button. And that just simplifies the if statement down here. So if R button, right, which is short for saying if R button equal 1, And so if our button is 1, then what we want to do is turn on the red LED, else turn off the red LED. And likewise for a green button or G button. If G button is 1, then turn on the green LED, otherwise keep the LED off. And so I'm going to go over and start building this thing on a circuit, but I'll just pause for a minute to let you just kind of take a look at this code and take it in. Okay, and I'm going to bring up my terminal. I'm working on a Mac here, and I've already compiled this code. So if I were to just type make, what it would do is it compiled. Okay, so I'm going to just show you what would happen. Suppose I were to compile it yet again. If I were to type make, all right, it says nothing to be done for begin. That's because once it's compiled, if you don't change it and you type make again, it won't recompile. Sometimes you want to force it to recompile, and so you would do this, make dash capital B, and that would force it to recompile, even though you haven't changed it since the previous compilation. Okay, so now I'm going to well, I want to flash it to the board, to the Arduino, but before I flash it, I'm going to go and build the circuit. So let me now turn on this camera here, and we'll come back to the code after we build the circuit. So here we have the Arduino, and we're going to be using, see here we have pins 0 through 7, and those correspond to port D, pins 0 through 7. So what we want is 3 and 4 are going to be for the those are the inputs. Those are for the red and the green switch. And then 6 and 7 are going to be the outputs. So to start wiring this, what I'm going to do is I'm going to take this red wire and I'm going to connect it to the 5-volt output pin. And I'm going to connect that to this plus positive rail on the breadboard. And then likewise, I'm going to take this black wire into the ground and I'm going to connect that down here. So now I know that I have power once I plug in the USB cable, I'll have power to the breadboard. And I'm always very careful, always orient the boards the same way. I like to have the red on top and the blue on the bottom, and I have the positive ground rail, that's our 5 volts up on top. I'm not ground rail, but the positive power rail on top, and then the negative or ground rail on the bottom. I always use a red wire anytime something is connected directly to 5 volts or to our positive voltage. And I always use a black wire when anything is connected directly to ground. That way, anytime you look at any circuit that I make, no matter how complicated the circuit is, if you see a red wire, you'll know it's connected to VCC or our positive voltage. You see a black wire, and that's going to be ground. Okay, switches. So, we have 2 different kinds of switches. We have the ones with 2 buttons and the ones with 4 buttons. We can use either. I'll use the 2 buttons because that's what you have in your kits. So I'm just going to put one in here. Okay, and then I'll put the red LED down. Now these LEDs, they have a long lead and a short lead. And the long lead is the anode. That's the part that goes toward positive voltage. And then the short lead is the cathode. That's the one that's going to go toward negative or ground. So I'm going to put this in right down here. And then I need a resistor. So I have a resistor here, and I'm using a 1 kilo ohm resistor. Put that in just like that. And then I'm going to need a wire to connect that. Let's see, I'm going to wire up this switch and this LED. So the switch is going to be an input, and that's going to go to pin 3. Okay, so that's on pin 3, and I'll connect that to one side of the switch right here. And then the other side of the switch, which I access from up here, is going to go to ground. So that way, when I press that button, I'm grounding this pin. And when I take my finger off of the button, then I'm not connecting anything to the pin. But instead of floating, it will be tied high to 5 volts automatically because we've activated the internal pull-up. So, and I'm going to be using orange wires for inputs and green wires for outputs. So I'll do the red LED. That's in pin 6, and that's going to come right here. So now I've got the red LED and button connected. You know, from pin 3, I go to a switch. The other side of the switch goes to ground. And then from pin 6, I go to a resistor, and then to the long lead of the LED, and then to ground. And now let's hook up the other button. You'll notice that, well, by the way, you'll be using long breadboards. That's what you have in your kit. I just found it's more easier to visualize when I do a video if I use a short breadboard. But in either case, you'll notice that these are all numbered. The columns are numbered. And I like to use, when I can, I use numbers that are divisible by 5. Let's see if I can zoom in and show you that. Here, I happen to put the first switch on 25. And I'm going to put the second one on 15. It's just sort of a one way. It's a preference I have of kind of, spacing the components, sort of in groups of 5. So I have to fight with the switch to get it in a little bit. Okay, but that's in there. Okay, let's zoom out. There's that switch. Okay, and that is going to go to PD4. All right, we have that switch. The other end of that switch has to go to ground. So I have another black wire. Okay. And then the last thing I need to put on here is my green LED. Okay, and I'll wire it up starting with the output pin. That's pin 7. So I'll just put that, maybe I'll put that in number 5, in column 5. And then I have my resistor, and I'm using a 1K resistor here. So it won't glow terribly bright, but it'll be bright enough for what we want. And then I have a black wire for ground. Oh, nope, mistake. And then I have my LED, which is going to connect from the other end of that resistor to ground. Okay, so assuming that we've hooked up everything correctly, then once we flash the board, then I should be able to press one button and the red LED glows, and the other button and the green LED will glow. So let's go ahead and connect that up. Okay, you'll notice that this power on LED came on. That's a good sign. That means that our circuit is not creating a short circuit to the Arduino. Okay, so now let's go back here and flash that code. Shrink this visualizer for a minute. Okay, so I'm back to my terminal, and I'm going to do make flash. Okay, and that seems to have been happy with all that. Now, just one thing to notice, if you look over here on the far left, we're looking in the folder called Blink Switch, and I have a number of different source code files here, and I have the make file, right? And if we look at the make file, then that's got the name switches 3.c, and it also has the port that my Arduino is connected to. You'll notice that I have these two other functions, main.elf and main.hex. Those were intermediate files. We don't need them, but those were files that were created during the compilation process. I could do this. I could type make clean, and now keep your eye over on the left side of the screen, and what you'll see is that those intermediate files are going to disappear when I do this. Oh, I did a typo. Okay, make clean. Okay, so you notice that they're gone, all right? All that did is it deleted those because we no longer need them. We needed them during the process of compiling and flashing, but once we were done, I just deleted them because we don't really need to retain them in our file. That's something you can do. It's an option built into the make file. Okay, so now back over to the visualizer here. And if we've done everything right, I press that button, okay, and I've got a red LED, and I press that one, and I've got a green LED, okay? And so that's the whole circuit. And so I'll leave you with that.